All right, welcome back everyone to the Beyond Clean Safety Burst Conference. The significance of the topics that we'll discuss throughout the rest of the day and the topic that we just discussed lies in the fact that we talk about working toward patient safety day after day after day. But as healthcare professionals, as sterile processing professionals, our safety is paramount in order to work toward keeping our patients safe. So that's why we dedicated this whole conference to your safety in the workplace. And again, a huge thank you to Sertal International for sponsoring this event. Our next speakers are Michael Matthews and Bron Keese. Bron is the Director of Sales and CFO for RST Automation. He is a preferred instructor for the Rutgers University Center for Management Development's Executive Education Program. And Michael Matthews is the Vice President of Analytics and Resource Development at Beyond Clean and also the Director of Clinical Education and Training for Northfield Medical. Many of the tasks in sterile processing are repetitive. And because of that repetition, it is also error-prone. This presentation will explore how technology can partner with sterile processing technicians like yourself to standardize and automate those repetitive tasks that will provide technicians with more time and more attention to perform higher levels of instrument inspection using human insight and critical thinking. So actually, before we get started on the actual presentation, I am going to do a couple of poll questions for you. Thank you for your engagement to the last presentation. So let's take a look at this poll question. And this one, you can actually type in your information. When you hear the word automation, what do you think of? And you can type in whatever you would like. When you hear the word automation, what do you think? I'll give you a couple seconds to type in just word association. Let's go. Happy Saturday. All right, and feel free to submit anything that you typed out. This next question, is your sterile processing department automated? Very general question, but in your mind, when you think of your department, is it automated? Okay, give you a couple seconds. Go ahead and submit your answers. All right, and let's see the results. Okay, all right. So 100% of all of you who submitted an answer to that question said no. So something that will be really interesting is during this next session, like I mentioned, we're going to explore how technology can actually work alongside sterile processing technicians to make your job and your environment safer. So without further ado, I'd like to welcome Bron Keese and Michael Matthews.
Welcome to Working Smart, how strategic automation and sterile processing improves morale, protects staff, and hardwire safety. And I'm joined here with Bron Keese from RST, and we're going to be talking about automation in the sterile processing arena. And I think that when most people hear automation, safety is probably not the first thing that pops into their minds. And so I think when I introduce this, a lot of people are probably going to think, I thought this was a safety conference. Why are we sitting here talking about automation? And that's exactly why we need to have this conversation. We're going to talk about how automation can improve processes and it can make things safer for both patients and for the laborers. And so, Bron, I don't know if is there anything you wanted to add to that?
No, Mike, I really look forward to talking with you about automation here. There's been a lot of advancements recently in technology. We've seen things like artificial intelligence and machine vision start to really create the way that we can interact with technology and the types of things we can do. So, and I think there's a lot of uncertainty and misconceptions about automation out there. And so look forward to really kind of busting some of those myths with you and talking about some applications of automation technology.
Excellent. All right, so let's get started. So first off, what is automation? So I'm a history guy. If you've ever heard any of my previous talks, you'll know that my big goal was to be a church history professor at one time. And so I love history. And I could not go through this presentation without at least discussing history in some sense, because this has been a really important development in what has defined our modern age is the concept of automation. And so first off, let's start with definitions. What is automation? Well, first off, it's a technology, obviously. It has to be concerned with performing a process, so it's very process-oriented. It does this by means of programmed commands, and it combines that with automatic feedback controls to ensure the proper execution of instructions, right? So that's a lot. There's a lot going on in there. So we're going to unpack each of those things individually in a minute. But before we do that, let's go into the historical part about automation, which is, let's talk about the first time automation was ever really implemented in a factory setting. And so let's look at this short video about automation being implemented at the Ford Motor plant in the 1940s.
But you can't come in. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. Come back tomorrow night and try again. But you can't come in. I know you've been drinking gin. You've been cheating around with other men. I'm busy and you can't come in.
So automation makes a huge difference in the American industrial setting. It immediately makes a new industry completely available. It kind of democratizes the automobile, makes it possible for lots of people to be able to have these things, and it employs a ton of people. It creates just this brand new revenue stream for the United States. So thinking then forward to where we are right now, let me ask you a question, and you can just ask yourself, is your sterile processing department automated in any way? And I think when I ask that, people will probably immediately think, well, no, we don't have assembly lines in our sterile processing department, or no, we don't have robots doing all of our jobs for us. But you may be surprised. You may be surprised at how much is actually already automated and how much of a difference it's made in your day-to-day life. So let's take a look at our first example, which is the automated washer disinfector. Now, this is a technology, right? And it is concerned with performing a process, particularly the washing of surgical instrumentation. And it does this by means of programmed commands. Just like, the temperature, the dilution of the chemicals, how many cycles it goes through, and each of those can even be customized to specific instrumentation. So you might have one generic instrumentation cycle that you run everything on, and you might have one that's for delicates. And so that can be automated entirely through a single programmed command. And of course, it's got these internal sensors that we use to monitor how well it's doing these things. And the whole goal of this is compliant reprocessing of instrumentation and doing that consistently. And so, like I said, I don't think most people think about this as being automated, but if you've ever been in a sterile processing facility where maybe you don't have an automated washer, I've been in a couple that didn't, or maybe you had one of those really horrible days where your automatic washer disinfectors, they broke down, and you were stuck having to do everything by hand. That happened to me a couple of times in my career as a technician, and I can promise you I still remember those days because they were so genuinely awful. Because doing all of those things by hand was miserable. All the soak times, the things get backed up, and all the work, everything that's bad about decontam just gets multiplied over. And that it's amazing how much we just simply don't have to think about that now when we get those automated washer disinfectors in place. So that's a very common one. Let's talk about a second one now that is newer but is growing, and I've actually seen this in a facility. Automated guided vehicle case carts. I remember the first time I saw one of these, I mean, it really was kind of feeling like you were in the future. It's these robots that will move case carts and move surgical supplies from an area like sterile processing to the OR, and it prevents somebody from having to actually go and carry these things around. Now, if you're in a smaller facility where the sterile processing is very close by, you might think, well, that's probably not that big a deal. But in my first two stints as a technician, I was in very large facilities. In some cases, sterile processing was sometimes, half a mile of walking away from the OR that something had to be delivered to. And, you're carrying sometimes very delicate equipment. You might be carrying very heavy equipment. And so that's a really big deal. Actually, the second hospital I worked at, sterile processing was in the basement. The OR was on the second floor. And so if you got a call from the OR that says, hey, that really heavy orthopan, we need that in the OR right now. I mean, you were carrying that heavy orthopan upstairs, and it's a lot of work. And the big deal that we want to make for this particular conference, is this is a safety conference, is think about the amount of wear and tear on the individual technician from doing that type of work. Walking around, probably not that big a deal. But walking around carrying heavy orthopedic pans, okay, you do that one time, not so bad. You do that every day for 10 years, it starts to add up. And I think right now would be a good time to mention that, Hank Balch, whom you heard speak earlier, had a LinkedIn live conversation with James Carlock not too incredibly long ago that they mentioned that there is an impending staffing crisis in sterile processing. And this is kind of well known throughout the whole healthcare industry, that the average age for a healthcare worker is going up. There's not enough new young people being brought in to replace the aging ones. And so what that means is that as the average age is getting up, people become more vulnerable to the type of wear and tear to their bodies that doing something like carrying heavy orthopans half a mile to an OR for 10 years really starts to wear on their bodies. And so this is a very important issue. And so now let's look at a second video that talks about these automated case carts.
The AGVs are here to help us deliver products, supplies, trash carts, and linen carts from each building at a much quicker pace. The abbreviation is AGV, but the AGVs really stand for Automated Guided Vehicles. The AGVs get to about 26 deliveries per day for each vehicle. It's important to have AGVs here because of the distance that the product has to travel. It's the most efficient way to get people the product that they need. The AGV navigation system allows for the vehicles to travel through this extensive tunnel system here at Rush. The AGVs have an eye spinning on top of the vehicle, and it reads reflectors upon the walls. So along the path, there are reflectors on each side of the walls. And as a matter of fact, here's a reflector here, and there's a reflector there. As the vehicle goes along the path, the eye reads the reflectors, and that lets the vehicle know where it's at. The AGV collision avoidance system is designed to stop abruptly when the AGV senses an object. There's a front sensor and there's a rear sensor. It causes a bumper trip.
Please remove object and path of vehicle.
When that occurs, the AGV stops and the AGV will continue going to its location or its destination. The AGVs serve patients indirectly, so the patients will never see what happens behind the scenes. Also, it provides for efficient delivery of products and services to the patient. This system is a 24-hour-a-day system, 7 days a week. The AGV will take power naps. The vehicle knows when the charge gets low to when it gets to about 50% to go choose or select a docking station, a charging station so it can dock and recharge itself. Currently, we have like 12 charging stations. There's something called a lift gate on the back of the AGVs, and that lift gate has a capacity of 1,000 pounds. It's about 11 of me. If they go down, we're prepared to get them right back in service and running again. In the command center, I'm looking at the monitors and I'm looking for certain errors. So if I see any error, if I notice any error on the command center screen, then I'll go out to that unit or that vehicle or the charger or the elevator and try to figure out what's going on with that vehicle.
Okay, very cool stuff, right? Like when I see stuff like that, I get really excited. And so the second question that I want you to kind of think of to yourself is, what do you think of when you think of the word automation? And we've already talked about kind of a couple of things that tend to pop into people's minds. I think it's important at this point to address some of those common myths that pop into people's heads and really kind of address them first before we dive into what this actually could potentially mean to your everyday sterile processing. So if we talk about myth number one is that automation always hurts jobs. And this has been around for a very long time. In fact, going back to my history roots here, if you've ever heard the term Luddite, this is a term for a group of people who they were actually clothing makers back in, I think it was the 1700s, that automation was kind of beginning to make its place there, particularly for yarn spinning. And they were angry about it. And so they were known for sabotaging and destroying these machines. And they became known for being anti-technology. And so sometimes you'll even hear that word kind of thrown around sort of like as almost as an insult, saying that somebody is a Luddite. It means that they're anti-technology. They don't want any technology whatsoever. This is one of the most common and long-standing myths about automation, that it will kill jobs. But now that we've had a pretty decent amount of history with automation behind us, we can honestly say that's just simply not the case. In fact, the reality is that manual processes tend to hurt people much more than automation hurts jobs. So go back to lifting heavy objects that we just talked about, running orthopedic pans back and forth to the OR that's far away. Think about, in those facilities where you didn't have those automated washer disinfectors, how if everybody had to be in decontamination, manually soaking, manually washing those pans to achieve those parameters that the machine just does automatically. Think about the wear and tear that does on somebody's back from leaning over the deep sink. And those constant repetitive tasks, again, it's those light motions. So it doesn't necessarily have to be that big orthopedic pan, that's 25 pounds, but you can get a constant repetitive injury from doing something very light just over and over and over again. So probably heard of carpal tunnel. Typing on your keyboard is not an exhausting thing at all. But if all you do is sit at your keyboard and type all day long, over time, it turns into this thing called carpal tunnel. And so that constant light repetitive action can absolutely lead to its own set of problems. And of course, the big one is unnecessary exposure to chemicals and sharps. Now, when I was doing some research about this presentation, one of the industries that has benefited greatly from automation is the steel industry. And of course, steel, obviously, they've had to use a lot of automation to move heavy objects around like steel bars and such. But one thing they've also started doing is automating those cranes because the crane driver was often exposed to dangerous fumes. And so all of that automation has actually helped prevent those hurt workers. And then it's also freed people up to pursue more complex, more engaging, and usually better paying jobs rather than, the job. You don't want to be the guy who just moves object A to place B all day long. That's not a very fulfilling job, probably doesn't pay very well. And instead, that job gets taken away by maybe one of these automated case cart robots. And instead, that person now gets to do something much more complex, much more skilled, more engaging, and it pays a lot better. So the reality is that automation really doesn't necessarily hurt jobs. It can cause some jobs to go away, but those jobs are often replaced by better jobs. The next myth we want to look at is that automation is always expensive. And again, I think we go back to that mindset of, well, I mean, we're going to have like robots walking around and doing exactly the same motions that people do. And, that's going to be impossible to create. Well, again, if you're thinking about Star Trek, then yes, in that case, yes, it would be very expensive. But I think the reality is that there is a huge amount of waste involved with manual processes. Again, think back to our automated washer example. If everybody had to do everything, manual clean and decontamination, think about how many sinks that would take. Think about how many people you would need in decontamination. All those people have their own labor costs. You're paying them. We're also paying for supplies like PPE for them to be able to do that. They're paying for their brushes. We're paying for their sinks. We're paying for their water. A big one is space. In fact, space is such a big one that we're going to actually talk about it in more depth on myth number 4 here in a couple of slides. But the point is that there is a lot of waste involved in manual processes, but we tend to not think about those costs because we've gotten used to them. In some sense, they're expected. And so because they're expected, you just simply don't think about them. Now, I want to enter in a little suggestion here that's not really necessarily part of this presentation, but you can take it. It's a free piece of advice for you. I highly recommend anybody in sterile processing sit down and figure out what does it cost for you to reprocess a single instrument. Do you know the answer to that question? In my experience, the vast majority of managers do not know how to answer that question. And if you don't know how much it's costing you to reprocess a single instrument, you're going to find it very difficult to overcome myths like this. But if you know how much waste goes into those manual processes, establishing a return on investment for something that's automated actually becomes pretty easy, and it becomes pretty easy lift at that point. Third thing is automation is always complex to manage. Now, it's one of those myths that maybe there's a little bit of truth to it because getting started can be a little complex. It does tend to take a little bit to develop and figure out on the front end. But the whole goal of automation is to make things simpler once the process is in place. Now, a great example of this is McDonald's. Now, I used to do a lot of traveling, and I knew that if I went to a McDonald's in my hometown, or if I went to a McDonald's on the other side of the country, if I order a sausage McMuffin with egg, it's going to taste the same regardless of where I bought it. Now, imagine for a second that McDonald's has no automated processes. They have no automated ordering. They have no standardized system for delivering food to their various restaurants. What it would mean is that no two McDonald's would taste the same. The one in my hometown could be amazing, and the one across the street is terrible. There's no consistency to it whatsoever. Now, that's what it would feel like to a customer. What do you think it would feel like to the manager of those individual locations? Well, they would have to do their own ordering, do their own sourcing. They would have to find this food. They would have to order it. They'd have to go get the food, get it delivered, all of those things. And it would be different from one facility to the next. How complex is that? It's unmanageably complex. And so the reason why things like McDonald's can exist and they can deliver those kinds of consistent results, and the fact that the managers don't have to think about where's my sausage coming from today, or where are the buns coming from today, which manufacturer is going to make it. They don't have to worry about any of that because it's automated now. So it can involve a little bit of work on the front end to start, but once it's in place, it makes things far simpler and far more consistent. And finally, this about space. So space is probably one of the least appreciated values in a hospital. You think about how big a hospital is, and they never seem to have enough space. There's never enough storage space. Again, we have this conception that automation requires like these massive assembly lines, kind of like we saw in the Ford plant, right? Where you've got, warehouses that are strung together and things are moving on this line. And, and people will look at that and say, I can't do that in sterile processing. You see how little space I have? But the reality is that when automation is done well, and when there's a lot of research and thinking put into place for this, it can actually make things far more efficient. Again, think back to the sink example. If we wanted to push through the same number of instruments out of our decontamination that we're currently doing with automated washers, but we needed to do it only through manual soaking and manual cleaning and decontam, how much space would you need in decontam for all those sinks? How much space would you need in decontam for all the people and all the supplies? So in this case, these washers, which take up, a pretty small footprint, actually save a ton of space versus doing things manually. So what is it that exactly we would be looking for automating in sterile processing? And so let's consider if the task is, if it's boring. I know that seems like a weird one, but if the task is boring, typically, if you're anything like me, your mind will start to wander. And so you're automatically thinking about, what am I doing after work? What am I eating tonight? What am I doing this weekend? Or maybe something, you've got some stress on your mind. How am I going to pay this bill at the end of the month? When you're bored, that's where your mind goes, and it doesn't stay on your task at hand. And that's when accidents happen. So, let's not write off boring thinking that all jobs have to be entertaining. Boring does matter, because if your mind is not focused on what you're doing, you will make more mistakes. Dangerous, obviously, there's a lot of danger in sterile processing that I don't think people are aware of when we talk about exposure to sharps, exposure to bodily fluids, exposure to cleaning chemical residues and vapors, repetitive tasks like we just talked about a few minutes ago, that it doesn't take a huge amount of weight to do a lot of damage to a human body if the task is just done repetitively. Complex actions. Did you know that reprocessing a flexible endoscope from start to finish takes over 150 steps to be issued, have to be performed in order precisely. And if you screw up at step 2, it really doesn't matter what you do on the steps 3 through 150, because you've invalidated everything else in between. So it's a wildly complex process. And so anytime we've got those wildly complex processes where one thing can invalidate the entire process, that's something that maybe automation should be considered. Accuracy driven, exactly what I was just saying, and of course time sensitive. So all of these things describe a lot of tasks in sterile processing. And so that's why sterile processing is such a key area for potential further automation. The goal is primarily to work with technology. It's not an either or. It's kind of, so if this was a logic class, we would call this a false dichotomy. That means that we often pin two things as opposed to each other, when in reality both can work. And so we don't have to say, do we want to have a human side to what we do, or we can automate? No, we need both. And we need to learn to work together in order to be safe and make processes safer for our patients. So I'm going to kick this over to Braun real quick. And Braun's going to talk about a couple of case studies where this actually has played out. Braun, take it away.
Thanks, Mike. I want to talk to you about how, as Mike said, when working with technology, right, we can actually see how technology can help improve staff morale, how it can protect the staff, and how it can really hardwire safety for both the technician and the patient, right? Because we've got a lot of people in this environment that are important. So I want to point out a few case studies here. Our first one is in instrument tray assembly automation. So, and what we see, right, when technicians are tasked with assembling surgical instrument trays, we see a process that is really an unstructured process in the sense that, if you have 20 technicians all assembling the same tray, odds are they're going to assemble it 20 different ways. Mm-hmm. So it's an unstructured process. It's a very error-prone process because of the complexity. And it's also very labor-intensive, right? It takes a lot of effort to assemble, especially large trays when we're talking about, right, trays that may have 150 or sometimes even more instruments in them. And what we see in this department or in this process is that oftentimes there's not enough labor available, or that labor is inadequately trained to meet the tray production demands that are put on the department, right, from the OR. So this is important, right? Because if we don't have the right people and we don't have enough of them, it's hard for us to, right, produce a quality product, right, for the operating rooms, which is what the SPs, right, often serve. So we want to make sure that all of these instrument trays, right, are accurately and properly inspected to just avoid, right, expensive operating room delays and ensure patient safety, right, which is paramount in this environment. So in addition to the productivity and quality benefits that we see from automated tray assembly, which we'll explore here in a little more depth in a few slides, we also get to see a lot better data coming out of this process, which really empowers management to help improve the process. So these automation systems that do tray assembly automation provide very accurate and very granular data that's never really previously been available to SPD managers from their current instrument management software. So, and as we all know, if you can measure something, right, when we're talking about processes, if you can measure something, you can improve it, and if you can improve something, then you can perfect it. And so when we talk about automation technology, what it fundamentally does is it starts to structure this process, right, and allows us to accurately measure this process. And once we have a structured process that we can measure, then we can improve it, and then we can perfect it. And we can use tools like Six Sigma, right, to really help us kind of perfect these processes and the quality of these processes. Now, for those of you who may not be familiar with Six Sigma is just one methodology that you can use for, it's often used to perfect manufacturing processes in order to minimize errors. And when we combine automated tray assembly technology with Six Sigma style process management, this really empowers technicians and managers to achieve real-world production excellence in surgical instrument tray assembly. So let's look at this process in a little more depth. So this slide you'll see shows us, right, the process flow before instrument assembly automation, and then the process flow after, right, instrument assembly automation. And as you can see from this process flow chart, assembly automation technology really greatly reduces the steps involved, right, in assembling surgical instrument trays. So this automation technology helps technicians by handling the identification, the counting, the sorting, and the stringer assembly of surgical instruments. And this allows technicians to really focus on their critical job of instrument inspection and testing. And what we like to say is that there are things that machines do well, and there's things that humans do well. And what we want to do to get sort of an optimal outcome is to let machines do the things that they do well, like identifying and counting and sorting instruments, which then allows the humans to focus on the things that they really do well, which are oftentimes the more complex and more important things, such as instrument inspection and testing. So technicians that are working with automated tray assembly technology really see a streamlined process workflow, and this results in higher quality, just a higher quality and more efficient tray assembly process. And even more importantly, again, this automation fundamentally structures, right, adds structure to this unstructured process, and it makes sure that trays are assembled the same way every time. And as we know, as we talked about, right, once we have process structure and we have actionable, accurate data, combined with some Six Sigma or other right management styles, that can really lead to excellence in production, which is what we're all striving for, right? I want to show you a little more data here, which this slide illustrates some real customer data that shows us the type of reductions in tray assembly times that are possible through automation technology. So we have seen tray assembly times reduced by as much as 70% when using automated tray assembly technology. That increase in throughput comes along with greatly improved quality. So the automation technology gets rid of many common errors in tray assembly, such as missing instruments or incorrect instrumentation in the trays. It also makes sure that the stringer order is correct every time. So we get this quality, we get this increase in throughput, we get a structured process that allows, again, technicians to really focus more on an instrument by instrument basis, the inspection and testing of the instrumentation. And we get this actionable data that now creates really a win on a lot of levels for many hospitals that choose to employ this automation technology. As another case study, I want to talk to you a little bit about another automation technology, and this time it's involving the process of peel pack creation. So current peel pack production in many facilities is just a very slow, it's a very disjointed and inefficient process. There's a lot of steps in creating a peel pack for an instrument. Right? Technicians need to first identify the instrument, then they need to usually look it up on their instrument management software and print the labels for it and determine the right pouch size and length and cut it, seal it, and print the label and apply it, and all these sort of disjointed, right, sort of steps that are really inefficient and lead to, in a lot of cases, a lot of material waste too, because you'll find sometimes technicians inadvertently create the wrong size pouch, and so then they have to throw it away and start all over, or they end up using, right, they may not have the right size available, so they use a larger size when it's really not needed. So you see a lot of just inconsistency in this process, a lot of material waste, and a lot of wasted motion just in general. And so here we see another opportunity to employ, right, some automation technology. So if we look at the process flow, and on this slide, we see the process flow before peel pack automation and then the process flow after peel pack automation. And again, you see that from this process flow chart that the peel pack automation technology really greatly reduces the number of steps involved in producing peel packs. That, and again, we fundamentally structure an unstructured process. So previously, if you had technicians, right, producing peel packs, again, 20 technicians producing the same peel pack, odds are they're going to do it 20 different ways, right? And it may be different size pouches. They may have different labels on them, right? There's really no standardization or structure in the process. So the automation technology really helps, right, overcome that by allowing, and the automation technology helps technicians in this area by handling the identification of the instrument, and it automatically selects the correct peel pouch size and the correct label. And it creates all those things simultaneously, by the way, which greatly reduces peel pack production times. It creates consistency in the peel pack production, and it reduces the material waste and cost. So you get the same size peel pack every time with the correct label on it every time, regardless of who's making them. And that just, right, it makes for a much easier and more enjoyable process for the technician, while also delivering cost savings and consistency, right, for facilities in the peel pack production. So I'll go a little bit deeper into that data. So if we look at this side, we again see some real customer data that illustrates the reduction in peel pack assembly times that are possible through automation technology. So we've seen peel pack production times reduced by 50 to 80% in many cases, from an average of about 4 minutes in a lot of facilities down to under a minute. The technology just allows for the ability to do double pouches as well. So if that's something your facility produces, there's a lot of flexibility in the type of output that can be created with the technology. And this better productivity, along with improved quality, right? You get the same pouch, the same label every time, less material waste because you're always getting the correct size pouch produced to the correct length, right? This makes automation, again, a win in this area for the technicians and the facility and the patients. So now, one thing that's important, I think, to point out here, whenever you're dealing with new technology, is that there's a learning curve, right? There's an adoption curve that we see in this technology. So when you first, right, introduce automation technology into a department, you expect to see a sort of adoption curve to it, right? It takes a while for technicians to be trained, right, for staff to be trained on the technology and to get familiar and comfortable with it. So it's not like you just flip a switch and all of a sudden, right, you've got automation. There's a ramp up that occurs, and this is really natural, and it's just part of sort of, right, it's one of the things you need to think about when you're evaluating and implementing automation in the SPD. And I think with that, Mike, I'm going to kick it back over to you to maybe talk a little bit more about that topic.
Yeah, absolutely. And I got to tell you, Brian, everything you're saying about the particularly the peel pack piece is really resonating with me, because I remember at one of my facilities, we had just a bizarre number of peel packs on a daily basis. It's just the facility's process. And it was so intense that we actually had to hire a part-time person to do nothing but peel packs. That's all they did. Because the peel packing, what was happening was it was waiting to the end of the day because nobody wanted to do it because it was repetitive and it was boring. And a lot of stuff wasn't getting done as a result. And so we had to bring in a part-time person to do nothing but that. And so when you're talking about the possibility of reducing a single peel pack by the time required by 80%, like, that's amazing, and what's going on there is with that simplified process is every time you take a link out of that process, what you're really doing is eliminating an opportunity for an employee to get hurt. And they're spending less time doing those repetitive motions that lead to those repetitive injuries. And so all of this the end result is it's more consistent and safe for the patient. It's less expensive, and it's safer for the individual technician that's performing the task as well as freeing them up to actually do something that's a little bit more complex, a little bit more engaging, and a little bit better use of their time. So if this is something that, people, I'm sure they're hearing they're resonating, these arguments are resonating. They're saying, yes, I would love to do something like that. But the idea of evaluating and then implementing in their sterile processing facility is very daunting because this is not common. This is not something that I think is probably top of mind for a lot of administrators. And the result of that is I feel like most managers feel like pushing through a new technology or a new process is 100% up to them. And you don't want that. I think that's one of the biggest problems that leads to manager burnout is this idea of, if I want to improve a process, I have to just bulldoze it through myself. And when it doesn't resonate with other decision makers, it falls flat on its face. And that's very defeating for that manager. And so it pays on the front end to really think through, okay, who do I need to talk to? What steps do I need to think through? What's the arguments that are going to resonate with each of these people? The arguments that you make for the frontline users when you talk about simplifying and making their days easier or reducing their injuries, that may not resonate with your director of finance or your vice president of finance. They're probably looking at a flat ROI. And so go back to what I said a while back when I said, do you know how much it costs to reprocess a single instrument? You need to be able to make those arguments to them if you're thinking about pushing something like this through. You need to identify who those stakeholders are and be able to communicate the value to them in a way that resonates with them. Next, this is going to be really important when we think about how you're building your department on sort of a day-by-day basis. You need to develop a culture within your department that is technology friendly. I've gone and spoken at a lot of facilities, and sometimes I'll run into people who will say things like, 15 years ago we did it this way, and now you come in here and tell us we're supposed to do it this way. Why is that? And the answer is because technology is changing. Our processes are changing. They're improving. And so, yes, the way that we're doing things today is not the way that we did them 10 years ago. And the way that we're doing them today may not be and probably won't be the way that we're doing them 10 years from now. And so being flexible and being ready to adapt new technologies is going to be critical for how you build your departmental culture. This is going to have a huge impact on who you're hiring, how you're hiring them, the way that you do orientation and continuing education, the expectations that you set for your department, like a mission statement when you tell people like, this is where we're going. This needs to be part of it, that we're going to identify new and better ways of doing things, and we're going to embrace them. And that's big for leadership too, right? So if you bring in a supervisor who says, I don't want to do new things because I did it this way for 15 years and I don't feel any need of changing, that's going to be a huge problem for you when you try to bring something like this on board. So setting those expectations for your leadership that we're going to be flexible and we're going to pursue new things because they make our jobs better and they make our performance better is critical. And everybody's got to be open and willing to change. Now, never forget the policies. And I fully understand that there is nothing exciting about policies. I find them to be painfully annoying in some ways, but they're critical. They're critical for creating the infrastructure that is going to uphold your department. And, keep in mind that when you are surveyed by somebody like the Joint Commission, they survey you to your policies. And what they want to see is they want to see that there are standard operating procedures in place, that they are well thought out, and they want to know that you are following them. And the reason for that is because that's what creates that standard process that's going to lead to a consistent and reliable result for your patients. Now, you're going to want to work with your vendor partners to ensure that you consider all the possible implications that need to be covered in written policy, and you need to get feedback from those stakeholders during the draft and review stages so that nobody is surprised. That's kind of the last thing that you want, is for anybody to be surprised by something that's going on. I think probably what's key, kind of the linchpin to each of these things that you have to consider, is that piece about communication. You cannot over communicate when it comes to implementing something new like this. So, really think through who's going to be impacted and how they're going to be impacted. What specifically is going to change and what's not changing. That's key too. And thinking about how it's going to impact that end user. And you want to tell them that on the front end. Because the last thing that you want is for, you've created all this cool stuff, you've created new policies, and then somebody walks in at 11:30 p.m., that's the third shift person, and they just get hit in the face with, oh, we've changed everything, by the way. Well, that immediately gets somebody defensive, and they say, well, I don't want to do that. Now I'm stressed out. I don't know what I'm doing. They feel completely overwhelmed, and they don't feel that they've been a part of that process, which makes them more resistant to it in the first place. So you really have to get in on the front end. But the key piece here is you have to be honest. there are going to be unknowns. And so if you just tell people that on the front end that, here are the unknowns, here are the things that we're not quite sure about, if things don't work well, take responsibility for that, because no process is ever perfect. And that's exactly what, Braun was talking about when he talks about that Lean Six Sigma. We may be pursuing a perfect process, but we aren't there yet. And so every little piece of information that you get back regarding those outcomes can be used to refine that process. Clearly establish, publicize, and remind the team about a go live date. Make it a big deal. Put posters up, send emails out, invite people. The more you celebrate it, the less it becomes something that everybody is anxious and nervous about, and something instead that people are excited and looking forward to. Now, that initial feedback from the new processes is very critical to making sure that it lasts. Talk to your customers, those end users. Ask if they've noticed a change. Sometimes the best thing you can hear is there hasn't been any change, and that's good too, because that means you've at least hit the same level as what you were doing beforehand. But maybe if they see a change that isn't positive, take note of that. See what you can do to adjust and fix. And if something is positive, celebrate that. Make sure everybody hears about the cool things that you're doing. It's going to help really build the level of morale within your department and the feeling of professional responsibility that those frontline technicians get. So this is really critical to raising that. Now, if, again, getting through to administrators is its own challenge, but there is never a better time to engage that C-suite attention than during the rollout of a new technology. Get them down there. Let them see what they did. You probably had to argue and wrestle with them quite a bit to get anything new implemented. Thank them. Make sure they know the positive outcomes that have come through. Don't let it be the last time that they ever hear from you was when they approved a new technology or a new process. No, let them know what kind of positive impact that it's actually had, because what that's going to do is it's going to build you up as a leader in that department, and it's going to make them more likely to say yes the next time that you come around and ask for something. Because they're going to remember, oh yeah, I disagreed with them at first. They won me over, and look at what it did. They need to know the successes that you're having. So that goes back to that ROI. Once you demonstrate that ROI, don't let that be the end of it. Bring it back to them, show them, say, hey, these are the numbers we thought we were going to get, and here's what we've got. We're saving money. We've saved this. Let them know that. And of course, don't even be afraid to reach out to local newspaper, industry publications, other platforms to communicate your department's progress to the public. Hospitals do this all the time. Think about how many billboards you've seen where a hospital is celebrating their new robotic surgery system, like your new Da Vinci robot system. Does that really have any impact on the people who are driving by? Probably not. But what it does is it communicates to the people who are driving by, hey, that hospital, they do things in new and exciting ways that hopefully will make patients' lives better. And so that's the whole reason they do that. You can do that too. And even if a local newspaper isn't what you want to do, put it on LinkedIn, put it on Facebook. Celebrate those departmental wins. It's going to help build your departmental morale, and they're going to love you for it. So today, obviously, we've been discussing automation, what it is, and how it can provide value to sterile processing teams. But we also really wanted to focus in on ways that it can make you as the employees safer. So we busted some myths. We talked about the topics, provided insight about what that collaborative automation means. We're working with technology. We're not working against it. And then finally, we provided this outline for ensuring that the evaluation and the implementation of our processes can work. And so the future of sterile processing is up to you. Where do we want to go from here? Do we want to keep doing things the same way that we did them for years? Or do we want to move forward? Do we want to make things safer for us and safer for our patients? I think I know, based on your presence here at this conference, I think I know what the answer is. I think you want to move forward. So let's go and let's have some fun. So we're going to open it up to questions now, and we're going to be on the line. So anything that you have, feel free to type it into the question and answer box there, and we'll get to it as quickly as we can.
All right. Thank you both, Braun and Michael, for that presentation on automation, increasing safety, increasing staff morale. I'm excited to open it up for questions because there are so many great questions that came through. So I'm going to give Braun and Mike just a minute to hop on. Just let me know when you guys are all set.
I believe I am here.
All right. And if you guys have this playing on your screens, please turn it off so we don't have any echo. That would be great. Welcome. All right. Wonderful. Braun and Mike, like I said, thank you so much for this great conversation. Let's start off. We got a question that came in that says, when we're more dependent on automation, is there then no chance of faulty or dirty instrumentation? Start off with a light question.
I'm bad with that one. Can you hear me okay?
Yep, we sure can.
Okay, great. So, no, absolutely, absolutely not. It's still, I view automation as really working with mission, right? So it sort of, creates what I kind of think of as maybe a super tech in a lot of ways, right? So it really kind of empowers the technician to just do their job, more easily, more enjoyably, hopefully as well, and with greater accuracy and greater productivity. But it by no way is replacing the technician because, again, as I said, kind of during the webinar, there's things that people do well and there's things that machines do well, and the key is just to divide those jobs up so that everybody can do what they do best, right, to get the optimal outcome. So when we're thinking about, there's no technology out there that I'm aware of that can detect dirty instrumentation or can inspect and test it for that matter. So, that's a very fine motor skill process that involves, far more intelligence that machines currently have. So, there's no way that we could do this job without technicians, right? And again, that's really, I think, one of the most critical things technicians do is when it comes to instrumentation anyway, that inspection and testing and making sure that the instruments are functioning properly and that there's no bioburden on them. And that's something that, just machines do not do well at all and is very important for humans to do and do well.
Okay, thank you. More of a general question. What are some of the challenges to implementing new technology, new automation in the sterile processing department that you're familiar with and that you can maybe provide some guidance to frontline technicians and department leaders on?
Sure, I'm happy to take an initial stab at that one too, Lindsay. I think the biggest challenges we see with facilities implementing technology is your biggest challenge is the status quo, and I think that's always the case whenever you're dealing with technology. Is the biggest challenge is always the status quo, and the fact that people don't like change. It's just not change is uncomfortable. It's not something we generally embrace, that most people generally embrace because it's new and it's different, and that doesn't feel right or good. So I think it's really important to get sort of everybody on board from the start, right? So, to introduce the technology to the departments, to collect their feedback on it, to answer their questions, to really get them sort of involved, and to also make sure they understand why, right? Why are we implementing this technology, right? We're implementing the technology because we want better patient safety. We want higher quality production. We want, less injuries, right, in the workplace, and we want ultimately technicians to be happier and to be doing the jobs that add the most value to the process. So it's important, I think, just to get everybody together to address their concerns up front, to answer their questions, to have them understand why it is right that this technology is being implemented, and to just make sure in general that kind of all the stakeholders in the facility are on board. So, it's important that the folks in the executive suites support this too and understand why it's happening, as well as the frontline workers and technicians that are going to be interacting right with the technology every day. Mike, do you have any additional thoughts on that?
No, I think you covered it really well, Braun. I think that, yes, there are a lot of challenges, but a lot of it goes back to learning how to speak the language that is going to resonate with those administrators and with your staff. Understand that the things that you talk about for one group may not be what you need to talk about with a different group. So really think through how to communicate those, and they'll get you a lot of credit for those groups.
Okay, wonderful. This next question I'm going to send to either of you. Tray assembly seems to take more time with some sort of automation, and this person believes that a good trained technician can do it faster. Handling one instrument at a time is very time consuming, and then you're adding testing and organizing in the tray. Can you speak to that?
Mike, you want to go first on this one?
Yeah, actually, I was going to kick it over to you, Brian, because you're the one with the data on the assembly. So I think leaning on the data is the key piece to this. And another big issue is you may be right about these super technicians that have been doing the job for 10 or 15 years and plus, and they know those sets inside and out, and that's great. But unfortunately, those people are declining in number. And we have more and more, let's be honest, we have a turnover problem in this industry. We have a lot of people who are in, for 6 months, 1 year, and then they're gone. And we're having fewer and fewer of those super technicians who are kind of those high producers.
Yeah, no, I think that's a great point, Mike. Well, one point is that yeah, exactly. Can somebody who's really experienced do a tray faster? They can, but remember, you want to be handling instruments one at a time, right? IFUs, you need to be inspecting and testing instruments one at a time, and it's something we see all the time when we watch, security videos in departments. Is you'll see technicians, especially with looped instruments, right? They'll take some looped instruments, some scissor-like instruments, and they'll pick up 5 or 6 of them at a time and inspect them, all at once, and that's just, to be quite honest, not safe from a patient safety perspective. It's directly against what the Joint Commission wants to be seeing, and unfortunately, it's what happens every day. And so, one of the things, again, that we like about the automation technology is it standardizes that process, it structures it, and it forces the technicians to handle the instrumentation one instrument at a time. And what we find, again, if we look at the data, is that on average, the systems help technicians, when you're talking about a one-time instance, okay, let's have a race, right? A one-time instance between the system and a really experienced super technician. Yeah, I mean, that super tech is likely going to be faster, right? But as you mentioned, there's a shortage of those people. There's not enough of them to go around, and the facilities don't have generally enough staff overall, right, to begin with, much less people who are really, really experienced. And two, the person doesn't keep up that pace the entire day, right? Day in, day out, 360 days a year, right? That's not the pace that they're assembling trays at. And so if we look at current production data versus the data once our systems are installed, we see in most cases a roughly 50% increase in throughput. So you're talking about average tray assembly times, usually for most facilities hovering in the 20 to 30 second per instrument range prior to adoption of tray assembly technology. And then we see that decline to about a 10-second per instrument pace. So really quite, and again, we can track this very, very granularly. So you can take that data, you can look at it by technician, you can look at it by tray type, by date range, by instrument type if you wanted to. So we know, again, exactly how long it takes to process every instrument in a tray. And the other thing it helps with too is it just helps sort out the quality of the trays too, right? So if you have instruments that aren't meant to be in there, but technicians have kind of historically just always put that instrument in because it was okay. Now all of a sudden you've got a stop gate to that, right? The machine's going to kick it back and say, no, that doesn't go in there. I mean, we can set it up to allow for substitutions if you want to do, something like that. But if you don't want any instrument in the tray, let the systems to enforce it essentially. So, So I hope that maybe answered, some of those questions.
Wonderful. All right. Well, it went by fast, but that is all the time that we have for questions and answers. So many great questions came through. So please know that I will get those questions to Bron and Michael so that they can answer them via email. Bron and Michael, thank you so much for providing this discussion on how we can discover ways in which automation can provide a safer work environment for sterile processing. Like I said before in previous sessions, we will take a 15-minute break. It's down to about 10 minutes at this point, but we will see you all in the next session. Thank you for joining us today.
Thank you.